All right, ladies and gentlemen, this week we put everything together that we've been talking about, and we started talking about chemical bonding, which is right more than one atom combining together, or two or more atoms combining together. And what we've been doing so far doesn't really change. All we're going to be working with is more than one atom at a time, right? But ultimately, the goal that we're trying to do is we're trying to make it so that all atoms are happy, right? Their outer ring is full, right? And we had two ways of doing that, right? You can get to 0 or you can get to 8, right? That was always the case last week in our lab. And that's the whole goal of chemical bonding is when an atom gives away its electrons, it has to be given away to something, right? It doesn't just give it away and those electrons are floating somewhere. They go to another atom. Same thing, right? If an atom is taking electrons, it's not taking it from like just random spots. It's taking it from other atoms so that it can have an outer ring that's full. And so the way the world works is that these atoms are combining with things that want to give and some want to take. So givers are going to combine with atoms that are going to be takers. So that's what we're going to be working on this week, right? As we're going. These are just a couple examples of what we see. This is sodium chloride. This is what you actually eat, salt, right? This is water, O2. Or I'm sorry, not water. It's oxygen. It's what you breathe in, right? O2. And then we'll talk a little bit more about what that 2 represents. And then MgBr2 is magnesium bromide. A lot of this stuff is road salt, right? When it's cold outside, these things. So it's magnesium and bromine combining together to make that. But again, I'll talk about that too in a little bit. Right. So there's 2 types of bonding that we're going to be discussing, right? It's ionic bonding, which is what we're doing this week. And then next week, we'll go over covalent bonding. So there's 2 different ways that electrons can kind of be given and taken in order to make all atoms happy. So ionic bonding is the transference of valence electrons. This is kind of very similar to what we did last week, right? There's givers and takers. Covalent bonding, we'll talk next week. It's about the idea of sharing electrons, okay? But just right now, this week, all we're going to be working on is this part right here, the ionic bonding. So what is ionic bonding, right? So ionic bonding is one atom is going to be a giver, and another atom is going to be a taker of electrons. And ultimately, what's going to happen is one of your atom is going to have 0 electrons around it because it's going to be a giver, right? All givers go to 0 to get a full ring. And then takers, right, are going to be the ones that get 8. So if you kind of look at the picture at the bottom right here, right, you'll see that this one is giving its 1 valence electrons to this one that needs only 1 more. So you'll recognize if you count it, this atom will end up with 8 valence electrons, while this one will have 0 around it. And that's basically the idea of all ionic bonding that's going on, right? And in this case, in ionic bonding, you only ever see a metal atom combining with a non-metal atom, right? This has to be the case. It can never be. You can't have 2 non-metals coming together, right? It has to be one of the atoms have to be a metal. One of the atoms have to be a non-metal as you're going through this. So what we're going to do now is we're going to practice how to show ionic bonding. Okay, so I'm going to give you guys 2 examples here of ionic bonding that you'll be doing for the lab, right? And just to show how to do that. So it's very similar to what we did last week, right? It's exactly what we did last week. The only difference now is instead of working with 1 atom at a time, you're working with multiple atoms at a time, okay? So here's the first one. So we have Na, which is sodium, and chlorine that are going to combine together, all right? So just like we did last week, right? We're going to go in here and we're going to look at the periodic table first, right? Because what we have to do is we have to figure out how many valence electrons each one's going to have, right? That way we can figure out which one's a giver and which ones are going to be takers. So if you notice, Na is right here, right? So that means it's got 1 valence electron. So let's get 1 valence electron right there, all right? And then chlorine is all the way on the other side right here. So if I'm counting the number of valence electrons, remember it goes 1, 2 valence electrons, skip over the short ones, 3, 4, 5th column, 6th column, and it's in the 7th group, right? 7th tallest column. So I'm going to have 7 valence electrons around it, right? So let's go around, put these on there. Okay. Again, I'm going to use different colors so that way you can kind of tell which one, where these electrons started, which ones go, and so on. All right. So you'll see that, right? Sodium right here has 1 valence electron. Chlorine has 7. And as I mentioned, right, in the notes earlier, one of the atoms is going to end up with 0 electrons around it because it's going to be a giver. And then the other one's going to have 8 around it because it's going to be a taker. So just like last week, right, we can look at each one separately and say, hey, sodium, is this going to be a giver, right, or a taker? So is it going to end up taking more electrons to get to 8? So that means it has to take 7, right? Or is it going to be more likely to give away its 1 electron to get to 0? It's probably going to give away that 1 electron, right? There you go. Right now, cool thing is, guess what? You got chlorine right here. It's got 7 valence electrons. What does it want to do? It probably wants to get to 8, right? And the cool thing is all it needs is 1 more. Well, guess what? Sodium has that 1 more to give away. So this is what happens when they give away. Sodium will come over here. Now, sodium doesn't just give away its electron and go, peace out, I'm out of here, right? No. What happens is now they end up combining together and become 1 molecule, right? Because sodium, even though it's giving away its electrons, it still wants it back, right? Eventually, right? It's just loaning it out to chlorine so that it has 8 valence electrons and that sodium has 0 too. But it's still going to want that electron back eventually. So that's how they connect together. And this is how chemical bonding works, right? It's the transferring of electrons from one atom to the other to now combine these two together. So instead of this being Na as 1 atom and chlorine being 1 atom, now they're combined together to make 1 molecule, right? Which is called sodium chloride, which is now salt, okay? Now, just like last week, right? One of the things that happened here is, guess what? Both of these now ended up getting the protons and their electrons are not equal to each other anymore because now they just transferred electrons, right? So sodium now has 1 more, right? Maybe I'll move this down over here. More proton than electron because it got rid of that electron, right? And chlorine now has 1 more electron than it does proton, so it's going to be a 1 minus, right? Now, if you do this right, your charges will end up canceling each other out, right? The 1 plus and the 1 minus, if you add those together, it becomes a 0. That's how you know that you did it right, okay? So that's another way to look at it. So you got a couple of ways to look at it. Number one of your atoms should have 0. The other atom should have 8, okay? If you've done that, you probably did it right. The other thing is if your charges, right, end up canceling each other out, you did something right. So this is just one example of an ionic bonding. Okay, let's look at the second one, MgBr2. This one's a little bit trickier because I have to tell you guys. Now, you guys probably took notes on this a while back, but I'm sure you probably forgot about it. But basically, the idea is this. What does that little 2, that subscript 2 mean? Okay, when it says Br2, what it means is that there are 2 bromine atoms, right? See how there's, in all these, it says Na, there's no number next to it. Cl, there's no number after this. That just means that there's only 1 atom. When there's a number here, Br2, that means that there are 2 Brs, atoms, in this whole process that we're working on. So if you look at it, I'm giving you guys 1 Mg atom and 2 Brs. So that means in this, right, chemical bonding, that means that there's going to be 3 atoms that are going to be combining together, right? So we'll figure out how are they going to combine together, right? So first thing is what we've done before, right? What we did last week, which is let's just do the electron dot diagrams for each one. So Mg, right? We'll see Mg is right here. So that means that it's got 2 valence electrons since it's in the second column. So we'll put 2 electrons around Mg. Okay. All right. Next is bromine, right? Let's look over here. Bromine is all the way over here. Okay, now I'm going to count actually backwards. Hopefully some of you guys have figured this out. But, right, since this column is my 8 column, I'm just going to work my way backwards. Instead of counting 1, 2, 3, 4, 5, 6, 7, I know it goes 8 and 7 right here. So bromine is in the 7th tallest column, right? So bromine right here has 7 valence electrons. So that means each one of these bromines are going to have 7 valence electrons. So I'm going to put my 7 valence electrons around it. Okay, 1, 2, 3, 4, 5, 6, and 7. Okay, all right, so here we go. Okay, so now we have to look at it and go, and this is where the kind of like the puzzle piece comes up. How do each one of these work out? All right, where remember, the goal is in ionic bonding is you know you did it right if one of the atoms goes to 0 and the other ones go to 8 or whatever. So you're going to have 0 or 8. So if you have more or less than that, you did something wrong. Okay? So if you look at it, right, we have to figure out, is it going to be givers or takers? So I know magnesium right here. It has 2 valence electrons, right? So I know that the key number is to get to 0 or 8. Well, magnesium most likely is going to give away their 2 electrons to get to 0. So they're going to give it away. So Mg is going to be by itself somewhere. Right? Now, each one of these bromines, let's look at this one, right, first. Right? This bromine has 7 valence electrons. Is it going to get to 0 or 8? Well, if it's at 7, it's probably easier to get to 8. So what does it need? It only needs 1 more valence electron, right? So it's going to take an electron. So it's going to take one of those electrons from magnesium. Okay? Now magnesium still has 1 left. Well, luckily, guess what? There's another bromine. And this is the reason why it has to be MgBr2 and not just 1, right? This Br wants to do the same thing as this one. It wants 1 more electron. It's going to take 1 more electron to get to 0, to get to 8. Well, luckily, Mg had, right, 2 to begin with because it can give 1 to this Br and it can give 1 to this Br. And if you look at it now, guess what? This Mg has 0 electrons around it. Happy. This bromine has 8 electrons around it. Happy. This bromine atom has 8 electrons around it. Happy. Okay? So now they're all happy, right? So, right? But now they're combined. Remember, when this magnesium gives its electron to that one and that one, now they're like, dude, we're sharing. Or not sharing, but we're connected now, right? If I give you my electron, you don't just, I don't go peace out and run away, right? I'm now connected to you. There's like an invisible bond that gets created when those electrons are being transferred, right? So now, what do I have to do around it, right? This gets where it gets kind of a little bit crazy, right? Each one of these atoms, right, all of a sudden now become, right, have different amounts of protons and electrons. Let me just move up a little bit more so I can get this all in. All right, so I have to show that the number of protons and electrons are not the same. So what's going to happen is, right, Mg lost 2 electrons, right? So what does that mean? It has 2 more protons, right, now in its nucleus than electrons. Each one of these bromines, right, this bromine gained 1 electron, meaning that it is 1 more electron heavy. So I put a 1 minus, right? Remember that minus and the plus sign don't mean add and subtract. It means which one do I have more of? Do I have more protons or do I have more electrons? Same thing with this one, 1 minus. Now, if I look at it, 2 things that tell me why I did this right. Number 1, this one has 0, 8, and 8. That's good, right? Now, if I look at my charges, I have 2 positives, 1 minus, and 1 minus. So if I took all this and added this together, they would cancel out, right? I would have 2 negatives and a 2 positive if I added these together. So I know that my atom or my molecule is good because it cancels each other out. Those are the 2 ways that you can figure out that they're good. So this is ionic bonding, right? As a whole. So like you can have more than 2. This one was the easy one because it had only like 1 and 1, right? The trickier ones are the ones where they start getting more and more atoms combining together, right? So this is what we're going to be working on in the lab this week. Cool? All right, make sure you put all this stuff into. All right, I don't want you just watching it. I expect that you're going to be putting in all these pictures or screenshots into your notes. All right, cool.